Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to take a look at the mathematics behind world, state, and city flags. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough-to-teach, tough-to-learn concepts accessible to all my students. And with us tonight, we're joined by Ken Collins and Ron Lancaster. Ken has a BS in physics and a master's in math from NYU and a PhD from Purdue University. He has taught for 56 years. I did say that correctly, 56 years in the middle school through graduate school. His focus is on the effective use of technology and applying mathematics to analyze current issues. He taught calculus and algebra 2 with extensive use of calculator technology. So Ken, it's really great to have someone with all your experience with us tonight.
Well, thank you. Thank you.
And Ron is an associate professor emeritus at the Ontario Institute for Studies and Education of the University of Toronto, where he taught mathematics courses for pre-service middle and high school teachers for 17 years. Prior to that, Ron taught middle and high school mathematics for 23 years in co-ed public schools at an all-girls school. Ron's professional activities include consultations and conference presentations all across the world. He's been an author for NCTM and the Ontario Association for Mathematics Education. Ron's been a national instructor for TI since 1994 and has conducted workshops throughout the United States and Canada on graphing calculators, motion detectors, and scientific probes. Ron is the recipient of the 2015 Margaret Sinclair Memorial Award, recognizing innovation and excellence in mathematics education, awarded by the Fields Institute, and most recently, the 2022 recipient of the Lifetime Achievement Award from the Ontario Association for Mathematics Education. So Ron, congratulations on that most recent award, and it's great to have you with us as well.
Mike, thank you very much. And I know my t-shirt looks odd. The square root of -2 equals 2. It should be 2i, but this is what happens when you lose an I.
I love it. Ken, will you start us off by talking through the agenda for tonight, please?
Well, tonight we're going to try to take a look at flags from a mathematical perspective. And we'll show how you can model some of these flags using the TI-84 or the TI-Nspire. And if we have time, participants could choose a flag and see if they can make a mathematical model of it and use that to have their students not only model flags, but what's very popular with students is to design a new flag for their school or for their club or for their town. So there are a lot of students that have been doing with that.
Thanks so much, Ken. And also I wanted to mention we do have a webinar drawing tonight, so stick around to the end. One lucky winner will be receiving a TI graphing calculator of their choice. And Ron, will you talk through our expected outcomes?
Yeah, Mike, you know, it's fairly basic here, but you know, the idea is I can help students view, excuse me, flags through a mathematical lens. It's going to be one of the big ones. You know, I can show students how to develop a mathematical model for flags. So as a teachers, we can model that for our students and then have them do it themselves. And I can help students to use some TI technology and coding to actually make dynamic models of flags. And another one too that we'll do at the end is I can become more aware of the resources that are out there. And we have a Dropbox folder that we put together. I'll have to put some files into it after this webinar, so it's pretty well empty at the moment. But within a couple hours, everything will be in there from tonight. Thanks, Mike.
Thanks so much, Ron. We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Ken or Ron using that Q&A window on the right side of your screen. And we'll also be using that chat window tonight to send general messages. Many of you have already kind of let us know where you're from. It's so great to see such an international community kind of getting together on these Tuesday night webinars. I love it. This session is being recorded, and we'll provide a link the event certificate of attendance at the conclusion of the webinar. So I think it's time for me to pass things over to Ron.
Thanks very much, Tim.
And Ron, it's all yours. Feel free to share your screen.
Fantastic. Thank you, Mike. So we're not quite sure how much we'll be able to get done here. There's a fair amount of things, but there will be a Dropbox folder with files in there, so you'll be able to go through, and take a look at things. So here's a quick quiz for you. So in the chat, can you identify these 4 flags? So do you know where these flags are from? And maybe since I have this open, Michael, if you could keep an eye on the chat and maybe call some things out, or Ken as well.
Sure thing. I'm ready.
Okay.
I was wondering if you could, I don't know about everyone else. I need a little more of a hint. Are these all on one specific continent? Can we narrow it down to a continent, or
No,
is
they're
that
from all over the world.
okay?
Yeah,
That doesn't
yeah,
help me then.
and they are gorgeous flags. It's interesting. I do a lot of math walks where I take students out, and one of the things we do, if we stop and there's a collection of flags, I ask my students to identify as many flags as they can, and then to express their answer as a percentage, and it's usually fairly low. We generally don't know a lot about flags, and flags are really a great way for us to get connected to the world. For students to become global citizens, to know more about a country. The flags can be a gateway to that. Are there any? So Kathy says in the 3rd quadrant, perhaps that's Jamaica.
I was thinking the same thing.
Yep. There any others at all?
Nothing else I see yet.
Okay.
But I'm with Kathy. At least the colors made me think maybe something along the lines of Jamaica.
Yeah. And Isle of Man. Oh my goodness, Mary Reeves, Isle of Man. Woo! So here's the answers. So where there is the Isle of Man in the lower right corner. What a cool flag. And you've got Guyana, you've got Seychelles, and you've also got the Czech Republic. So the beautiful flags. So in the chat for a moment, with these 4 flags, what could be a mathematical question that you could assign to your students about these flags? Now, this is really tricky to do in a chat. You can't put in equations, and you can't write a book here. So just some brief thought about the kind of thing that you could ask. And if you can't think of a question, what do you notice? What when you look at these flags, what do you notice? What do you see? So maybe do it from that angle as well. This could be a great exercise for your students about noticing and wondering. To look at flags and ask that question. What do you notice? Anything coming in here?
Yeah. What percent is for each color in the flag?
Beautiful. Yeah, Mike, Ken, if you read them out, that would be great.
Yep. I said, what are some of the vocabulary terms that come to mind with each of these flags? Just trying to get students to identify vocabulary that they know, and then try to make that relate to some of these flags. Bayram said, finding the areas of the colored regions.
Beautiful.
I think that'd be interesting too. Yeah, that's what we have. Angela said shapes. Mary said angle measures. I think I saw another symmetry, areas of different colors. Which flag has the most shapes from Manual?
Beautiful.
I like that kind of question because I feel like this could really apply to lots of different mathematics content areas. It's not just focused on one area.
Yes.
I like this a lot.
Has anybody mentioned equations?
Not yet.
Okay. Well, it just got mentioned. So, for example, the flag in the upper right corner of Seychelles, it'd be interesting to find the equations, for those lines. Of course, that would mean that you'd have to decide where you put 0, 0. Where does it go? And that's kind of open-ended here because it's, you could put it anywhere. so you're going to get a variety of different equations, all with the same slope, but different y-intercepts, depending on where you put 0, 0. Oh, wow. Neil says, which one is closest to the golden rectangle? Where the aspect ratio of the flags is the closest. Wonderful. Yeah, well done. Tessellations, very nice. Could you use any of these for a tessellation? Great question or great comment. That's really well done. That's excellent. What about these? So these 3 flags. So maybe instead of questions, just what do you notice? Because there's kind of an obvious question about the area of the circles, in terms of the whole flag. Imagine if your students could make dynamic models of these using TI technology so that they could play with the radius of the circles. And they could, this is a bit subjective, but they could look at it and say, I like this one better. This looks a little bit, in my opinion, this looks a little bit nicer than that one. But so Michael and Ken, what are you seeing about comments here about what people notice or questions for that matter?
Yep, so we have mention of patterns, another one about map colorings for the regions. I mentioned that the dark red looks centered, but the other 2 look off-center. Someone else said that one is centered and the other 2 don't appear to be. Yeah, that symmetry right off the bat kind of caught my eye.
That's beautiful.
Another person said calculate the probability of hitting the circle.
That's
and then
beautiful.
to defend your calculated answer.
Wow. Yeah, that is great. You are correct, by the way. Those circles, the 2 circles on the right-hand side, they are not centered. Whereas the one for Japan is. This isn't obvious when you look at these 3 because of the way I've lined them up. But there's something unusual about these flags. Oh, by the way, how does the color reflect the culture of the region? Wow, that is a great question about color. And, I have a whole collection of books about flags. And a lot of these get into the reasons for the choice of flags. Like, why is it that Bangladesh is green and red? And why is it that Japan is a red circle? So for most flags, there are reasons for this. It's not like whatever. They didn't wake up one morning and say, well, I think we'll just, stick a red circle in the middle. There are historical reasons for those choices. This is a really nice way of bringing history into your classroom, as well. Because of the way I presented these, Ken and I have presented these flags to you. This may not be obvious, but I'm going to stack them going down. I'll do that in a moment. The aspect ratio of these flags, the length to width. For Japan, it's 2 to 3. For Palau, it's 3 to 5. 5 to 8. For Palau, rather, Bangladesh is 3 to 5. Very interesting. Do you notice the Fibonacci numbers?
Mm-hmm.
And golden ratio? You were talking about golden ratio before. If you do the Fibonacci sequence and you go further and further out and do the ratio of successive terms, it gets closer and closer to 1.618. So there's very interesting ratios here. That's what they look like if you stack them. You might have thought they were all the same rectangle in the first view. They're not. They have different aspect ratios. So the ratio of the length to the width. The Canadian flag has an aspect ratio of 1 to 2. The length is 1, the width is 2. They have names for these things in flags, hoist and things like that. And maybe we can just move on here, but this would be another good one to use with your students. Is, you could design some questions, for this. But just here, and maybe instead of questions, just what do you notice about the flag of South Korea, the Republic of Korea? What do you notice here?
Bars are all different.
Yeah, absolutely. There's something going on with those bars. Mary Reeves says hexagrams. Wow. Something going on with this design. This is one of the most beautiful flags. It turns out that is the definition of the flag of South Korea. It is very prescriptive. The aspect ratio is 2:3, and everything is nailed down here. The radius of those circles, the length of the bars, the width of the bars, everything is there. So there's a lot of different math questions you could ask here, and especially creating this with TI technology, to be able to put this up on the screen of the calculator. There's a great deal of mathematical thinking that you would have to go through to be able to do that. Coordinates, points of intersection, lots of stuff. If you're wondering about those bars, it's base 2. It's actually the binary system. Those bars are all connected to base 2. It's amazing. 111 is Earth, 000 is heaven, and so on. Amazing stuff. So this will be in the Dropbox folder for you, and you'll be able to come back and take a look at this, but this will be a great flag for you to use as well. The proportions of flags, the aspect ratio, is remarkable. If you just take a look at this list, look at El Salvador. This is fractions on steroids. The aspect ratio is 189 divided by 335. Like, what is that about? Like, who would wake up in the morning and say, well, I'm going to make the flag with that aspect ratio? I mean, there's got to be a reason for this. And there is. And when you start to delve into the history, you'll see that. Nepal is just unbelievable. There's a number field video that's done about Nepal that is remarkable. So that's something you might want to look up, is Nepal there. So what I'd like to do is model for you taking the flag of Scotland and putting it on a TI-84. And then what Ken is going to do is model it with the flag of China. You have to start somewhere. And I think we both feel, Ken and I, that, if you want students to be able to do this kind of thing, you have to model it for them, and kind of outline, the kind of things that you could do, and then let them do it, so that they have some idea of where to start, with this. So if you're going to assign this to your students, the very first thing that your students are going to need to do is to do some research. So find out, everything they can about the design of the flag, the specifications of the plan, to be able to develop your mathematical model. So I did that. So I did some research online, and I found that the aspect ratio of this flag of Scotland, well, this is a country that is quite unusual for its flag. It's could be 3:5, it could be 1:2, it could be whatever. It could be 3:5. Most countries have it really nailed down, but the flag of Scotland is a bit like, which one is it? So anyway, I went to another website, and this one actually has a different relationship. So this is different. Then I went to a third website with another one. So this is a third version of the flag of Scotland. Like, what the heck's going on here? So, and this is a fourth one. This is one where it's like the open box problem, where you make squares in the rectangle. So generally speaking, when your students pick a flag and look it up, they are going to get absolute specifications for the flag. There are some laws in the country about this is what the flag looks like. But Scotland is a bit sketchy here. So I would really suggest that you have your students work with Scotland at some point, maybe not for their first flag, because you're going to get a variety of designs, and then you can compare them and see which one you like the best. Now, I belong to this flag association, and so I recently reached out to Ted Kay, who is involved with NAVA, and I said, so the flag of Scotland, like, what should I use? And he connected me to Philip Tibbetts, who turns out to be this huge expert in Scotland and flags. And Philip said to use this. So this is the one that I used for my mathematical model. And I don't know about you, but when I first looked at this model, I was a little bit kind of concerned because I was thinking, how am I going to make this? Like, what am I going to do? I mean, the width of that stripe is 6 units. And how am I going to go through and design this? It wasn't totally obvious to me, at the beginning. So I fiddled and fiddled and fiddled. I got out some paper and I put this down on a piece of paper, and this is eventually what I came up with. So I took, I took the 50 units by 30 units. That was a choice as well. I could have used 100 by 60, but I chose 50 by 60. And I drew lines in and drew in circles. I was trying to guarantee that, I had the width of that as 6 units. So the radius of the circle was 3 units. And then eventually I did some trigonometry to figure things out. I wanted to develop some equations for this. So I needed the slope of these lines. So some basic right angle triangle got me the slope. And again, this will be in the Dropbox folder and you can go through this at your leisure. But it's just basic trigonometry being used to get the slope. And then I can put in a coordinate system. And again, this is a choice. Where do you put 0, 0? Do you put 0, 0 in the middle of the flag? In the upper left corner? Upper right corner? Like where? It's up to you. And depending on what choice you make, it's going to change the y-intercepts of your lines, not the slopes. Anyway, I decided to put it in 0, 0 in the corner 0, 0. And then I was able to go through and actually get the equations. So this is the prep work needed before you work with the graphing calculator. So I went through this and did that. I was able to get the equations of the other lines. There's some really good mathematics here. There is symmetry here between the lines. So the slopes of the lines going uphill are 0.6. The ones going downhill are minus 0.6. So there's some really nice mathematical connections here. Lots of stuff here. And then I started to code. And as I coded, I realized, oh my goodness, I need some points of intersection. So I needed to know the coordinates of O. I needed the coordinates of N and other things. And so I was kind of flickering back and forth between the coding and my mathematical model. I was generating more things as I figured out that I needed them. And that's a typical thing that your students will do. The coding creates a need for more mathematics, which is really cool. So there was a reason why I needed the points of intersection, because I was trying to draw the lines. When you draw the flag on a TI-84, you don't want to have the whole line. It's pieces of the line because the middle is empty. So that's why I needed those points of intersection. Anyway, eventually I was able to set up coding for it. We're not going to belabor this here, but that's the coding of my first attempt. And one of the beautiful things when you code is I ran this and it was like, oh no. I looked at this and I thought, hey, those lines are going off the flag. Darn. And so like, what am I going to do? So then I went back to the mathematics and I thought about piecewise defined functions of setting up the equations so that they didn't go off the flag. So as I say, I was flickering back and forth. This is my initial version of it, and I'll show you the somewhat final version here. So there's a little bit of housekeeping going on here where it's getting the equations put in, and then it's doing the shading and going through that. Points of intersection were important here, of knowing how to shade, and then putting it in the middle. And lots of mathematical questions here about the areas of those triangles. the area of the white relative to the blue, and so on. So that's what it looks like for a flag. And I guess what Ken and I are suggesting here is the idea of you modeling this for your students and giving them a bit of an idea. And this could be done in a video, where you go through, what you've personally done to develop some equations and what you did with the coding, to put that in. And that is a beautiful assignment for your students. Have them take a flag and do it. And, in your class, every student in your class could get up for a minute and they could talk about the country that they got, what language is spoken there, what's of interest in the country, what do they manufacture, where is it, what's the population, whatever. So, within a short time in your class, everybody could get to know more about the world and countries around the world. If you don't have time for a presentation like that, then have posters set up in your room where the students make a poster and they're put up in the classroom or in the hallway. And by the way, Ken and I are both proponents of interweaving curriculum. If you say, oh, nice idea, but I got no time to do this, linearity just kills mathematics when we do everything in a linear fashion. We start at the beginning and we just kind of march through the curriculum. If you interweave the curriculum and occasionally and bring content together in one activity, you can save a lot of time. And it's more interesting for kids and they'll remember stuff better. But it is possible to address the time issue. So that's Scotland. So what Ken is going to do is talk a little bit about what he did for this flag. So this is the flag of China, and it's certainly more complicated, than the flag of Scotland. So Ken did some research, and Ken found some information about the flag. And Ken, I'm going to turn this over to you. So I'll go to your file. Ken, should I open up the first file so that people can see the research part of it? Or is
Sure.
that in your file?
No, yeah, go ahead and open the first one.
Okay. Yep.
That's fine.
Okay. Okay.
Okay.
So this
So
is from the research that Ken did.
yeah, and you can expand that a bit. Thank you. Okay, so the flag of China is very specifically defined, and actually, you can break it up into 4 quadrants, and quadrants 1, 3, and 4 are just red, and all the action is in quadrant 2. And in quadrant 2, we've got a large star whose center has to be in a very specific position in terms of how far it is from the top edge and the left edge, and also how large the radius, in this case 3, of the star is. And then we have 4 stars that are around it, and their centers are also very specified by the flag design. And one interesting thing about the small fall of stars is that each one has a vertex and a line of symmetry that points directly to the center of the large star. And so there's some interesting math involved that we'll get into as to how do you have the stars arranged so that they'll do that. And there's a lot of symbolism involved here. As you might expect, the large red star symbolizes the Chinese Communist Party. And the 4 smaller stars, there have been various interpretations for them. Some of them describe the 4 major population types that are in China. In the early part of the Chinese government, the 4 stars represented the 4 classes of people that were in China: the workers, the farmers, and the low-level bourgeoisie and the upper-level bourgeoisie. So And there's a history of that is interesting to read. Of course, China has a very long history, and so that's all sort of involved with this. Okay, so
That's pretty amazing because that is so unlike, I mean, the flag of Scotland has reasons for the way it is,
mhm,
but it's kind of, vague, but this one is really nailed down, as you
yes.
pointed out. Do you want your second file open, Ken?
Okay, so the just as a final comment, what we're really going to focus on is that quadrant 2, what's going on there. And then after we finish constructing that, it's going to be fairly straightforward to go ahead and expand things to see the whole flag. So we're going to literally use the second quadrant of a graph here. So I've got this set up so x goes from -15 to 0 and y goes from 0 to 10. And there's a 3:2 ratio here, which was fairly common. So the large star, according to the rules, has to be sent in this coordinate system, would have to be centered at -10, 5. So 5 units in from each side and has the radius of 3. So I thought that we should use at least 2 different types of ways of describing the circle. One, goes back to the, basic form using the Pythagorean theorem and then solving for the 2 solutions. And then we can go ahead and plot that. And then the next issue is, where do you put the points to form the star? How do you find them? And how do you find the lines that connect those points? Okay, so if you go down a bit, Ron, we
Okay.
have the
By the way, Ken, your use of the parametric equations, I thought was pretty cool. But we could certainly do that with basic right angle trigonometry as well.
okay. So you'll have to go up a bit because it's you go up to where you have the 2 slides with the graphs.
Um,
Go up further.
okay.
No,
I
you're going
can't,
down. Go up.
okay, I can't go up anymore, Ken, because that's the top. Oh, sorry.
Okay.
Yep.
You can go up to
Sorry
the
about
top of
that.
the page.
Yep, sorry.
Okay. No, further up. Go way up to the top of the page.
Okay, sorry, Ken. Somehow when I opened it up here, I'm gonna just close it down here
Okay.
this way and then come up.
Okay, great. So terrific. So if we take a look at the 2 middle slides with the stars, the first one, they're both the same graphs. In the first slide, we have the description of the circles, and in the second one, we have the parametric descriptions of the 5 sides of the star. And so basically, we know exactly where point A is at the top. And so, and we can measure the angles, angle ADC. So that's going to be 72 degrees. And then we know that the slope of that line will be equal to the tangent of 72 degrees. And so using the slide to the right on the graph, you could see at the very top is the equation of the side that's going from the very top sort of down and to the left. And the other ones are described in there. And there's one that's horizontal, we see, and that's the one that has y is equal to 6. So those are the parametric equations that describe the 5 sides. And then if you go down a little bit further on to the 2 slides below that, you
And
begin
Ken,
to
it's
see.
interesting that if somebody doesn't teach, um, the parametric equations, students could estimate those coordinates
Oh, yes.
from a piece of graph paper, or they could
Yes.
use some right angle trigonometry to come up
Yes.
with the same thing in a different way without the parametric. I love
Yes.
what you've done.
So these two slides basically go into the details of actually finding the equations for the sides of the stars. And it's basically done in a fairly consistent way, except for the one horizontal piece, which is sort of special. But you're using the angle of elevation or angle of depression, and then using the fact that the slope is a tangent of that angle, and then using that so that the x expression has the cosine in it, and the y expression has a sine, and so sine over cosine gives you tangent, which represents the slope. And so it's all basic use with parametric equations to describe those. And again, you will have a copy of this that you will be able to access and go into the details, so I'm not going to belabor that, but I just wanted to point out the general idea here. Okay, Ron, so if you could go down a few more.
Okay, just going to be careful doing this, Ken.
Yeah.
You tell
Okay,
me
so
what.
those next two also describe the getting the sides there. So all 5 sides are described. Okay, we can
Okay.
go down another 2. Okay, so stop there. Okay, so then after we find the sides, then we're interested in finding the smaller circles and smaller stars. And so the first thing I did was, again, use how the flag is specifically described to put the centers of the big star and the 4 small stars arranged on the screen and labeled, and you can see that. And then it's going to be very useful to have the segments that are connecting the center of the large star with the center of each of the 4 small stars. And so I set that up. And again, it's easy to do this with parametric equations because you could see the slope, like in FG, you can see how many units it goes over and how many units it goes up and get the slope from that. And so when you write the parametric equations, which are right above the slide on the right, you could see that it's all starting, from point F, the center of the large circle, and going to those other points using the slopes that you see. So those lines are going to be useful as we continue to describe the stars that are the small stars that are around the large star. Okay, Ron, so you can go down to the next 2 slides.
Right down in there.
Right, so that's good. Okay, so here, once we have the center of the 4 the circles, then we're going to go ahead and draw the circles themselves. And this time I'm using parametric equations to draw the circles. And in this case, the x-coordinate will be the x-coordinate of the center plus the cosine of the angle t, and y is the y-coordinate of the center plus the sine of the angle t. So and if you put that in for all 4 of those, you will then get those 4 circles, okay? And then, and so the next thing we need to do is ask ourselves how we can get the stars in the circle, and so they're pointed in a way that they're pointing towards the center of the circle. Okay, so this is where those lines that we drew connecting the centers become important, because where those lines intersect the small circle, that is where we want to put one of the vertices, and that'll be the vertex that points towards the center of the circle. Okay, so how do we identify that point? So if you take a look, say going from center of the large circle F to the center of the highest small one, G, we could see that the slope of that line, it goes over 5 and up 3. So the slope is 5/5. So the angle of elevation that line makes would be given by the tangent of that angle would be 3/5. So the angle itself would be tan inverse of 3/5. And you can, use that in the calculator and then store that. And I call that A degrees for that. Okay, so if we take a look at that slide on the right on the top, we notice that angle A, to find out where the point is starting from, the positive direction to the right, how far you have to rotate around. You have to rotate 180 degrees to get to the other side of the circle, and then you have to rotate further by angle A. So in terms of the angle description using parametric equations, that angle is 180 plus A. So that gives us the vertex of that's going to be pointing to the center. And from that point on, every other vertex is going to be 72 degrees away. So all you have to do to get the other angles is just to keep adding or subtracting 72 degrees 4 times, and it automatically gives you those other points. And so I have a description of that in the slides below, but then I went ahead and showed for the top circle where those 5 points would be. And then in the slide underneath, it shows how I used tan inverse, stored it in A. Now I have my calculator set in radians all the time. So it gave me a radian answer, and I went ahead and changed it to degrees. And then on the slide on the right there, it shows how I go ahead and identify those coordinates using the 180 plus A, and then the subtract 72 again. And you get, and then I do the same thing with the Y coordinates. Start with 8 sine 180 plus A, and then go ahead and keep subtracting 72. And I label these points with letters, these numbers with letters. Okay, and then if you take a look at the lower left screen slide that Ron has on the screen, it finishes up that description of the 2 coordinates. And then the nice thing you can do is you can store these as a set and have a set of the X coordinates, and I put that in set O, and a set of the Y coordinates in set P. And then when you go to a scatter plot for the graph, you can just put in O for the X coordinates, P for the Y coordinates, and it goes ahead and plots all of them. And that's how I got the points on the circle on the upper right. Okay, and you do that with the other 4 circles. So the next couple of slides describes that, and I'm not going to go into the detail of that because I have the details on the sheets there, so that, if you need to try it for yourself and see if it matches, that's fine. But then once you have that, then as you could see on the graph that Ron has, no, don't go down, go back up again. There you go. You see the 4 small circles with the 5 vertices located in each of the circles. And so now the question is, how are we going to draw the sides? Now we already have the coordinate points labeled. So all we have to do is join those points, okay? And I did that using parametric equations. So that's what the slide on the lower right Ron has on the screen is describing. And again, we use the points and label the points. And then if you go down one more, there you go, stop there. Okay. Then we have all of the points labeled with coordinates. And then to go ahead, and then the slide on the left shows how to go ahead and load that into to get the points plotted on the screen. And then the next slide that Ron has in the lower left illustrates how you can go ahead and use parametric equations. Now, with all these points labeled we can just go ahead and substitute in the labels for the points, and those are just numbers in there for the coordinates, and develop the 5 sides of the star with those parametrics. And since we're using the endpoints of the vertices for the endpoints of the line segments for the star, the t just has to go from 0 to 1. So that describes, the first circle, and then the other ones are described just as well in the subsequent pages. So now we've got those 5 stars, and so we have everything we need for the flag. What we need to do is to get rid of all of the accessory stuff. So that basically means turning off equations. So you go ahead and turn off the equation for the circles, for the centers, for the segments that connect the centers, for the axes, for the grids. You can turn everything off. And when you do that, you get the graph that Ron has on the bottom left, which is just in the second quadrant. And then finally, we change the window so that instead of just going in quadrant 2, we go ahead and double the y and x values to the right to show all 4 quadrants. And then that final slide is the geometry picture of what the flag looks like. And so this takes some time to do, and one thing I like to do is work in groups. And so one of the nice things you can do is have different groups work on different aspects of this, and then each group can sort of share with the other groups what they've done and how they put it all together. So it's a very pretty pattern, and it uses a lot of math. And I haven't touched on the issue of, coloring it in. I thought that just doing the geometry of this would be enough for tonight.
Ken, that is absolutely beautiful. And for everybody here, I think the thing that Ken and I have tried to do here is we wanted to pick something that was a bit meaty. The one from Scotland is a little bit complicated. The one from China is ultra complicated. But we just wanted to kind of share with you the process, of doing some research, figuring out what's your game plan. And I think it's the game plan that is really valuable here, where your students are getting a chance to actually think through, so what am I going to do? And even if you didn't make the flag, I think the game plan is really valuable. Saying that, okay, I'm going to start here, and then, somehow I'll calculate this, and with that I'll do this. And so they kind of write out a plan of what they would do, with this, to put together the flag. The dynamic nature of this, like what I could have done in the flag of Scotland, is, it was all about the width of that part of the saltire, that 6 units. Within the program, I could have that so that it's A, and I could vary A, and then I could look at the result. And so I could see different versions of the flag. Ken could do the same thing. He could set it up so that those 4 small circles are closer, or they're further apart, the pentagrams rather, or they're bigger. And, just to your eye, do you like it better? Or is it kind of nice the way it is? So the dynamic nature allows students to, because really that's what happens in design. People design a logo, they play with something, and they kind of alter stuff, and they just kind of play with the balance of things and say, I like this. This is what it's going to be. So we could add that dynamic nature to what Ken did and what I did too. Ken, that's really beautiful. For those of you who don't use parametric equations, it'll be a nice challenge for you to think about how would you do this with right angle trigonometry, to come up with all of these different pieces. And what could you do if you simply just estimated the points, and then work through some of the mathematics with that. So there's different ways that you could approach this, overall. Ken, thank you so much. It was really beautiful. I'm
Thank you.
looking forward to loading this on Nspire and taking a look at it. and seeing it. Any other comments about this, Ken?
Well, what I liked was that it integrated a lot of things that are not normally done in a math class, and there are a lot of things I thought where you could have students in different classes, certainly in a history class or in a sociology class, gain some insight from the analysis of the flag, and vice versa. The other areas could lend some more understanding to the history of the flag, its meaning, and
And the art teacher could be looking at it from an artistic point
definitely
of
the
view.
art. Yes,
The choice of the colors, the sizes, the subjectivity of looking at the design, and liking, the way it looks. Yeah, well done, Ken.
thank you.
I'll come back to our PowerPoint here. So that's the flag of China. I think we have about 10 minutes here, so we weren't quite sure how this would go. I think this was really valuable for you to see us speak about our developing the plan and kind of what we did. But if there was time, we were thinking of actually having you pick one of these flags and think about a plan. This would be a good thing for your homework or for to do with your students to pick the flag of the Czech Republic. Like, what is your game plan? How are you going to put that on TI technology? Where are you going to put the origin? How are you going to make those line segments? What are you going to do? The one for Cuba is also wonderful. Like, where will you put 0, 0? And how will you get the equations? That also involves some beautiful right angle trigonometry. Um, the one for the Maldives, I know it looks complicated, but it's just a couple circles. Um, that is a nice one to do with students. The one on the left-hand side is kind of, it looks complicated, but it's straight line segments that you're working with here. But Vietnam is also a wonderful one, similar to the work that Ken just did. By the way, it's interesting when you look at flags of the ones that have stars, the ones that don't, and so on, with those. Something that you might want to do with your students is to take a look at the flag of the town that you live in and maybe think about having your students redesign the flag. This is happening all over the place. I often get these messages from the flag association I belong to. This is in Euclid, Ohio, where high school students actually redesigned the city flag. It went through a whole process. The whole town voted on it. They went and presented it to City Hall. These are the high school students presenting their flag. This could be a wonderful project for your students to do, as to come up with a design, for a flag. As far as resources go, this is the best $40 you're going to spend. And I have no benefit from telling you this. I don't have stock in this association. But for $40, if you join NAVA, it is unbelievable. You'll get a great little magazine called Good Flag, Bad Flag. There's Vexillium. I get 4 of these a year. It's a journal that has all kinds of stuff in it. They have special flag books. This is a book on American flags. This is dozens and dozens and dozens of flags from cities in the US with the specifications. Incredible. And they have one in Canadian flags as well. So it's a great organization for you to join. A lot of resources. And there's tons of books. I have a collection here of books that I've got here, but some of them are quite interesting from a historical point of view. A Flag Worth Dying For. This one is Rejected Designs of the European Flags. So it looks at flag designs that were rejected. And then there's just all kinds of other books that, have lots of information about flags. Why don't country flags use the color purple? So this is a children's book that is really cool. So there's, I'll put in pictures of all of these into the PowerPoint here. I don't have all of them here, but there's a whole bunch here for you that, you may want to get and have in your classroom so that, or in the library of the school, maybe ask the librarian to bring in some of these books. A lot of these can be, found online too. This is our link for the Dropbox folder. So, I just noticed here that I didn't put in the link. So, Michael, are you able to email everybody at the end?
I can't email, but I can drop the link into the chat window. But
Okay,
they're
what I'll do is
automatically going to get, yeah, they'll automatically get an email with all the links after the
Yep.
webinar in a couple of
I'm
days.
gonna do it right now. So, this doesn't have a lot in it right now, but it will. And I'm going to put some files in there. This is the link to the Dropbox folder. So, so you've now got it there. And I'll put that back up so that you can see the PowerPoint file. And there's our email addresses and the QR code if you need that, as well. And, later tonight, I'll put some files in there, the PowerPoint file and other stuff, as well. We really thank you for coming, and we hope that, we maybe managed to inspire you to, think about using flags more. Maybe you already do, or maybe using flags for the first time, so that, you can, make some connections between the mathematics you teach and the world around us for your students. We thank you very much. And Michael, thank you so much for helping us out here.
No problem. We're going to begin to wrap things up. Last couple minutes here. We did promise at the beginning that we're going to give away to one lucky winner a TI graphing calculator of their choice. And tonight's lucky winner is Carrie Weekle. So Carrie, congratulations. We'll be reaching out to you over email in the next few days to get some more information from you. But that way you can have a couple of days to start thinking about which graphing calculator you want to select. To receive a certificate of attendance, go ahead and click the link that's about to appear in the chat window. Also listed is a link for the documents there as well. And if you're watching this on demand, go ahead and copy that link into your browser to receive your certificate.
And Ken and I are happy to answer any questions by email. We'd be happy to go over a few things with you if you have any questions about what we've done and, and to speak about it. And we would both love to see what you do with your students. And that way we can learn from you as well and to see what happens in your hands with this idea. Thank you very much.
Thank you.
And when you leave the webinar tonight, a brief survey automatically appears in your browser. Your feedback guides us as we plan future online events, such as events like this. This is really helpful to have your input and your thoughts on what we're going to do moving forward. So please feel free to reach out to us in the post-webinar survey. Huge thanks again to Ken and Ron. I know that it probably took a lot of time to create not only the documents, but also to make some of the math and the coding work. So kudos to sticking with that and putting that time in. We really appreciate it. Thanks so much for supplying all those documents. I know that's something that I think all the teachers that are on tonight are going to appreciate. Ken, I know just looking through your document quickly, it was extremely detailed. So that's certainly going to be helpful for a lot of people. So thanks to both of you. Thanks to the people that joined us tonight online. And we hope to see everyone back online next week. Have a great night, and we'll see you soon.
Fantastic. Thanks, Mike.
Thanks. I just noticed that there were a couple of typos in mine, so I have corrected them.
Ken, what you can do is I won't be putting things in for about an hour or two.
Yeah.
And even if you send them to me tomorrow, I can put in the new ones, but just send me the corrected version.